Welcome, friends, to this series of learning containers and Kubernetes. So, in the last couple of lectures, we saw how we can build the Docker images. Also, we learned how to spin up the Docker containers. We ran the Docker containers and build the images through Docker build or Docker run commands. But if we go deep into the infrastructure as a code, we need to learn how we can build the template of Docker containers. We can create the network, we can create the images, we can spin up the containers with the help of Docker Compose. So Docker Compose is a tool for defining and running multi-container Docker applications. If you have missed the earlier videos where we discussed various parts of Docker containers and Docker builds and Docker networks, multi-container systems, multi-tier microservices, we are recommending to watch those videos as well. We are providing the links in the description below. If you haven't subscribed to this channel, please do it right now so that you will get notified whenever the new videos will come. So now let's get started. In this particular video, we are going to build a multi-tier applications with multiple Docker containers. And instead of doing this through Docker commands, we will do the infrastructure as a code through Docker Composer. So Docker Compose is a tool for defining and running multi-container Docker applications. Like we can have one container for hosting the application, and maybe the other container we have to run the database. So the app container will communicate with the database container, and this is how this multi-container application will be built. With Docker Compose, you can use YAML file to configure your application services, networks, and volumes. This allows you to manage complex applications with multiple interdependent containers in a declarative manner. Some of the key features definitely we can think of single configuration file where you can define your entire application stack in a single Docker Compose.yaml file. This file specifies the services or containers, network, volumes that make up your application. It will have the declarative syntax. The Docker Compose.yaml file uses a declarative syntax, making it easy to understand and modify. You describe what you want, and Docker Compose handles the orchestration. Docker Compose is ideal for applications that require multiple services. That is, a web server, a database, a cache. It simplifies the process of linking these services together. You can define environment variables within the Docker Compose file or in a separate .env files, allowing for easy configuration and management of different environments. Docker Compose allows you to define custom networks for your services, making it easy to control how containers communicate with each other. You can define and manage volumes to persist data across container, restarts, and manage shared data among containers. Now, let's have a look what are the basic components of Docker Compose is. First is services. Now, these are the different containers that make up your application. Each service runs one image and can specify options with ports to expose, volumes to mount, and networks to join. And the networks define how services communicate with each other. Docker Compose can automatically create a default network for your services, but you can also define custom networks. Volumes are used to persist data and share it between services. You can define volumes in the compose file to ensure data is not lost when containers are recreated. Now, let's jump to the console and we can see how we can build multiple containerized system with the help of Docker Compose. Now, this is our fresh system having nothing in it. We can see there is no Docker containers are running. We can see there is not a single image right now at the server, and we can see only the default networks present in the host machine. Also, there is no volume at all. Now, let me show you there is a Docker compose.yaml file that I have built, which you can see how we can write this Docker Compose and how this will help to build a multi-container system. Now, through this Docker Compose.yaml file, we will build one application where you can see our Mine app will be in a network which is exposed to external world. But the database itself in a private network, whereas the mainnet is not, it is exposed to the external world. So no one from the external world can reach to the database. So the database in a secure private network. But the Python application can communicate with the database because it belongs to both of the networks and it can fetch the data from the database and serve it to the external user. Now let's see the Docker Compose file, how this is achieved. So you can see there are two services. One is My App and other one is MySQL. So this My App will actually build a Docker image which is written in the Docker file. And it is in /root directory. Now, this particular My App container will run the service from 5000 port and it is mapped with hosts 80 port. Now, if you can see what exactly this app will do, let me open the Docker file for you. It is the same Docker file that we built in the earlier lecture, and you can see what exactly the details is mentioned in the Docker file. So it is actually building the image from Python Docker image, and then it is creating one file system /app inside the container, and then it is going to copy this app.py inside this /app. And also it will add the requirement.txt inside the /app, and then it is going to use the /app as its working directory, exposing this 5000 port, installing all the dependencies, those are written in the requirement.txt, and then it is running this command to run the Streamlit application. And if you find this app.py is basically a Python code that is actually taking the environment variables from the containers system, and then it is going to use this database configuration to connect to the MySQL server, and the Streamlit application will provide the button insert item, and then it will insert the item to insert into statements. And similarly, the show item button will actually fetch all the data from test table. Now, this particular app will be built through Dockerfile, and this is what it is mentioned over here in the build phase. And then as this 5000 port will be run through Streamlight application, you can see over here in the Docker, we have mentioned that server port will be 5000, and we are exposing this 5000 port from the container. Now this 5000 port is actually mapped with 80 of host machine. And then it is going to provide the environment variables. Now, these environment variables are actually the database connections, and it is basically this my app is on both networks. One is MyNet and one is private net. Now, if you go below to this network section, you can see there are two networks are created. One is MyNet, which is a bridge network and open to external world. But this private network is again a bridge type, but it is an internal network. So this particular private net cannot be accessed from the external world, and it is completely in internal network. And we are also providing the subnet CIDR range, which is 10.2.0.0/16. So any container that is going to be created inside this network will pick up the IP address within this range. Now, we are going to create this MySQL service or MySQL container inside this private net. So if you see, this MySQL service is created in private net. And it is also assigning one IP address 10.2.0.2, which is nothing but one of the IPs in this range. So we are basically asking Docker Compose, please create the IP address, please create the MySQL container having this IP address from this network's IP range. Apart from that, it is creating one volume, which is MySQL data, which is nothing but the volumes that is actually mapped with barlab, barley MySQL containers volume with /data. Now, if you can remember in the earlier lectures, we created the MySQL container and we use the /data as volume mapping so that all the data till now created in the database is actually stored in /data. So when we create this MySQL container, it will automatically get those data. Those are actually created in earlier lectures. So this is how we are going to create two containers. One is my app and the other one is MySQL. MySQL is directly going to be fetched from Docker Hub, but my app is a custom application and we are going to build the Docker image from Dockerfile, and then we are mapping the port with 80 of the host port to containers 5000 port, and we are actually providing these connection details, and we are going to create this my app in both of the networks. And we are specifying this particular my app is actually depending upon MySQL, so that Docker Compose will create the MySQL first, and then it will create the my app Docker container. Now, let's clear the screen and let's see how we can build the Docker image and spin up the Docker containers with the help of Docker Compose. So this is the command docker compose and say up. Up means we are going to run the containers. And if we say down, that will actually shut down the containers. So we are going to create the Docker images and spin the Docker containers with the help of Docker Compose. So Docker Compose up and minus D is basically the same, like we are going to run these things, run these containers in background, and we are going to say build because we are actually going to build the my app Docker image. So now it started to fetch the MySQL from the Docker Hub because it is the first one, and my app is actually depending upon this MySQL. So this Docker Compose is smart enough to identify which is the one to create first. So after creating this MySQL container, it started to build the Docker image for my app, and it is actually having 11 layers, and currently the fifth layer is actually going on. So now it is actually using the Python Docker image, and then it is going to create the slash app directory, and then it added these both app.py and requirement.txt inside slash app, and now it is running the dependencies, whatever is written in requirement.txt. Now, once this installation will be done, the sixth step of 11th step will be completed. And right now it is actually installing the Streamlit and other dependencies. Those are mentioned in requirement.txt. Now, it will take some time. Once it is done, it started to exporting the image and exporting the layers. And now you can see the network root mynet, root private net, are created, and then it spinned up the container. So let's verify whatever it has done. So first and foremost, we will see the Docker PS, and we can see there are two containers are running. Now, first, let's see what exactly is root my app 1A. So we will say Docker inspect, and we will mention root my app -1. So you can see this particular my app is actually attached to networks, as we mentioned. One is root mynet and root private net. Now, first we will check what exactly the root mynet is, and we can check the networks right now created by these Docker Compose. We can see the root mynet and root private net. Those are actually created as a part of these Docker Compose configuration. So let's see what exactly root mynet is. And we can see the root mynet is actually a network which is exposed to external world, and it can be accessed from anywhere in the world. And also we can see a random subnet, because we did not provide any subnet for this root mynet network, so it created one subnet for it by default. Okay, nothing special in it. Now we will check what exactly is private network. So we will copy this one, and we can specify Docker network inspect root private net, and we will see this particular network is actually a internal network. So no one from the external world can reach to this private network. And as well as it has created one subnetwork range that is 10.2.0.0/16. Now, it is having one container for my app and other container for the SQL. So we specifically mentioned that 10.2.0.2 would be the IP address of the root MySQL one container. So it is created inside this network with the same IP address. So if we can again see Docker PS, we can now find this root MySQL one, which is the Docker container of MySQL one. So we can say Docker inspect this container, MySQL container, and we can see the IP address is 10.2.0.2, which we mentioned in the Docker Compose file. So if we once again see the Docker Compose file, we can see we had mentioned this IP address for MySQL container, and we specified that it should be created under this Creve network, and this is what it actually created. So it created this MySQL under the network root Creve net, and which is a part of this 10.2.0.2/16 range. Now we are okay. So right now we have created two Docker containers. One is Python root myapp1 and the MySQL database container, which is root MySQL1. Now this particular app is actually running inside the container through port number 5000, but it is mapped with 80. So now let's access this app from the web browser. For that, we need to know the external IP address of this host machine. And for that, we will actually check the IP address by curl if config.me, and it will provide the IP address 34.31.198.38. Okay. So now if we say HTTP and then the server name, and we are not specifying any port because the default port is 80, we can see our Streamlit application can be accessible. So we can, if we click the show items, we can find 3 items are actually being shown, and this is actually fetched from the database. As we can see, our slash data, which is actually containing the data in the earlier lectures, we created the containers and we used slash data, and we can see the data is preserved, though at the beginning of the lecture we saw there is no containers, no image, no network, nothing was there. But as the data was as it is inside the slash data file system in the host machine, that the data actually got protected. Now, let's go to this web browser and try to insert one more item, that is item number 5, and we can say Docker Compose, and let's insert this item, and we can see the 5th item is inserted successfully. And again, if we click the show item button, we can see the 5th item is successfully inserted. So this particular MySQL database is not accessible from the external world, but the My App Python application can communicate with the database server internally, and this is how we can secure our database server from the outside world. Now, thanks for watching this video, friends. In this particular lecture, we saw how we can build a multi-tier web application through the Docker Compose, and this is how we can build the infrastructure as a code, and we can in fact code our infrastructure through Docker Compose in the microservice world. Thank you for watching this video. Stay tuned. We will be coming with lots of new videos in this series. Thank you and have a nice day. Bye.